Hello and welcome. Thank you for having me. I'm Valerie Woolard. I'm a software engineer at Heroku, where I work on our data infrastructure products. My Twitter handle is Valerie Codes. It's at the bottom of every slide. Please tweet at me. Your mentions nourish me. Today, I want to talk about fear. I want to talk about the ways in which we experience fear and uncertainty. I want to talk about talent and the ways in which we imagine it in our peers and in ourselves, and how none of these problems are new or unique to our industry. This talk is entitled Code and Fear because it was heavily inspired by the book Art and Fear, and I'll be using quotes from Art and Fear to illustrate some of these points. We're going to discuss talent, art, and software development. First, we'll talk about the parallels between art and code. Then we'll see what we can extract from that to think about the way we do our jobs and the code that we write. I like to have GIF breaks. Here's the first one. Let's get started. My parents are both in the art world. My father is a photographer and my mother was a museum curator until she retired a few years ago. I think they always harbored a hope that I would grow up to be an artist, and as a teenager, they got me this book called Art and Fear. It's about the day-to-day life of being an artist, including the process, the frustration, and the doubts that are inherent. In typical teenager fashion, I didn't read the book, ignored their advice, and became a software developer instead. In terms of rebellion, mine was pretty mild, but a few years ago, I happened to pick up this book again. And in reading through it after working for a few years as a developer, I found its message resonant to the world of programming as well. We'll be taking a look at some quotes from the book and how they apply in our work. Some of you may recognize this view, maybe from a desktop background. This is Yosemite, and this picture was taken a few miles from the house where I grew up. I spent a lot of time around artists. One of the authors of Art and Fear took this photo and is a friend of my parents. Art, creativity, and inspiration were frequent topics of conversation in my household as a child, but it wasn't something that I thought had anything to do with computers. After all, computers are predictable, reasonable, and logical. To be honest, that's probably why studying computer science never really occurred to me. So, what does art have to do with programming? Before I discovered programming, I thought I would be a type of artist, specifically a writer. Programming always seemed too dry, too scientific for me. But it turns out programming involves a lot of creativity. Two people's approach to any given problem may be completely different, and to be a good developer requires technical expertise as well as creative problem solving. I think that we owe it to ourselves as developers to think about this aspect of our jobs more. It's not just about gathering technical requirements, it's about finding a way to fit them all together without making a mess. Programming is a creative pursuit at its core. It requires an understanding of the constraints of our tools, as well as an imagination for how those tools can be combined to meet an end. You're not a machine in which specs go in and programs come out. You're an individual who brings their own process, preferences, and biases to everything that you do. You're in no way interchangeable with another programmer. Many of the aspects of programming and developer culture that people find toxic boil down to an inability to grasp this fact. By dismissing a text editor, language, framework, or process, you're ignoring the fact that other programmers' processes are not your own. Their preferences and thoughts are not based in objective truth, and nor are yours. Here's another GIF break. So art isn't easy. In the same way that the work of an artist is often idealized and chalked up to short bursts of energy or genius, many people think great software is created by single lone wolf geniuses over the course of a manic weekend. To a lot of people, software development is that scene in the movie The Social Network, where Mark Zuckerberg builds Facebook in a frenzied night of Red Bull and Emacs, and the rest is just marketing. while in fact, software development is a process of fits and starts, of gradual development and rewrites, of trying to fit disparate pieces together without really knowing if it will work. Like art, software doesn't arrive in our heads fully formed. It takes work to refine an idea into execution, even if the execution at the time we first think of the idea seems clear. Like art, the role of inspiration in writing software is overstated, as there is a long road from an inspiration to a finished product. Like art, software development involves translation of ideas into action and an eventual result. The idea may be more or less nebulous, anything from change the color of this button, to send an email when someone fills out this form, to create a product that will make $1 million. The more refined the idea in the first place, the less divergent different executions might be, but there's always some degree of the unknown in what your code will look like or do exactly until it is done. Here's a comic that encapsulates this feeling from the art side. It's from Tiny Snake Comics. A lot of art making is a struggle. You might hit a flow state every now and again, but most of the time you're just plugging away. So why is it so hard? Making art provides uncomfortably accurate feedback about the gap that inevitably exists between what you intended to do and what you did. This process is hard because things don't actually fit together as well as we want. We've all had the experience of taking on something that seems very clear and straightforward, only to realize as we try to implement it that it is neither as clear nor as straightforward as we initially believed. It's a natural part of being a programmer, or really any kind of creative worker, that your end results do not always match your ambitions. The hope is that as time goes on, you will become better accustomed to what is possible and what you are capable of, such that the software that you imagine is closer in form to the software that you write. But even so, the most perfect version of something is always the version in our head. I think of this as the programming equivalent of that Tiny Snake comic. As with art, our code never turns out as clean or as well structured as we imagine it in our heads. In software more so than art, it's easier to blame this on external constraints. We tell ourselves that the systems have been set up in ways that make it impossible to achieve what we've set out to do as simply as we would like to do it. But it's also true that we have a tendency to underestimate the complexity of tasks. We can also feel this about systems that we ourselves have set up. Even given the desire to achieve simplicity and a good understanding of our parameters, the results can often feel cobbled together. As we imagine our programs in their best forms, we imagine all of the things we know to be possible in their best possible configuration. We also tend to underestimate the constraints of the tools that we work with, the time that we have, and the scale that we need to achieve. There are many considerations at work in making software, and elegance and beauty are generally not high on the list. As satisfying as it may be to write or read beautiful code, constraints of time, data, or existing systems can make it difficult or impossible. In an industry that prides itself on abstractions, abstractions are hard to see when you're searching for the most straightforward path from point A to point B. Writing efficient code can sometimes mean writing less readable or clear code. It's more straightforward to loop over all possible permutations than to build a hash table and perform lookups against it, but it's more efficient to build that hash table. Many of the tools that make our programs faster make them less intuitive, and deadlines mean we often don't have the time to be writing beautiful code in the first place. I've given an example here of two methods that should produce the exact same results. Both will return double the integer passed into them. The first uses your typical multiplication method, and the second uses a bitwise operator to shift the bits of the integer one space to the left, in effect multiplying it by 2. But most people would have to look up what that means and what this operator is actually doing. So while it may be faster on a computational level, it's slower on a human level. So which are you optimizing for? The answer may be different depending on your context, but it's worth thinking about. With every choice that we make in code, we're shutting off other possibilities. Part of the difficulty of programming is coming to terms with those decreasing possibilities and realizing that no solution that we envision is exactly suited to our needs. All of the tools that we're working with, existing code bases, programming languages, frameworks, and even the code that we ourselves write is a product of humans with their own constraints of time, imagination, and ability. Most of the skill involved in programming is not in avoiding these trade-offs, but in learning how to efficiently evaluate them and avoid making decisions that will lose you development time in the future due to the need to backtrack. One example that comes up early in the life cycle of an application is what your data schema looks like and what data storage system you're using. There's no single right answer, but in making that decision, you're making a choice about some of the things that will be both possible and impossible in the scope of your application. The sheer number of these types of decisions in the beginning of a project gives a good explanation for why it's often so hard to get started. To all viewers but yourself, what matters is the product, the finished artwork. To you and you alone, what matters is the process. Our users don't care about the process of building software. They don't care about what our code looks like or how that code came to be. Understandably, they care about how well our software works. Yet the process of building is important to us and our teammates. You might wonder why. After all, you can delete the spec folder from a project or decide to use tabs instead of spaces, and the code will function the same as before. And even people who see your code won't care about when you started work in the morning or the temperature of your coffee when you started reviewing code. But our process matters because it affects whether we produce good work that we're proud of. You may find that your teammates find your code more readable when you spend a few hours sketching out the architecture on a whiteboard before putting fingers to keys, or that your code is more effective when you write your tests first, or that you simply enjoy writing code in the morning and reviewing it in the afternoon. Pay attention to these things. How you write code is not important to the outside world, but it's important to identify what makes you the happiest and most effective. You'll probably recognize this top example as a very straightforward hello world program in Ruby. The second example is written in a programming language called Cheese++. It's a programming language in which all of the commands are related to cheese. As you'll note in the above example, the begin and end keywords are cheese and no cheese. These programs produce the same output, so there's really no reason to prefer one over the other, right? So who is it that really cares? You do. You care that your code is readable. So does your team. Deleting your spec folder doesn't change the functioning of the code that you've already got, but it makes it much harder to add or change anything without accidentally toppling the whole house of cards. We choose languages like Ruby not only because they're suited to our programming needs, but because they make us happy. Matz has famously talked about how Ruby was designed with the idea of optimizing developer happiness. He said, "I emphasize the feeling, in particular, how I feel using Ruby." This seems reasonable, given that a computer doesn't care what language you're writing in as long as it has clear instructions, and a user doesn't care what language software is written in as long as it works as intended. Even if it doesn't work as intended, those faults are likely to be attributed to the author of the software than the language in which it was written. So choosing tools with which you are adept and comfortable becomes even more important. As much fun as Cheese++ is in a demo, writing anything of substance in it would be incredibly arduous because the keywords are arbitrary names of cheese, and there are no libraries or third-party code for you to draw from. Sometimes the code you write is only for you, but you may not know that as you're writing it. You make good work by, among other things, making lots of work that isn't very good, and gradually weeding out the parts that aren't good, the parts that aren't yours. One of my biggest fears as a developer used to be deleting code, because I thought if I worked on code for hours and deleting it, I was just wasting my time. Luckily, I have managed to get a little bit better about this over time, but I still need to be reminded. Most code that I write is not good code, but writing bad code is part of the process. Writing bad code is the way that I get my ideas out there. Then I refactor. Sometimes I just write or prototype something to get an idea of an approach and end up deleting it and starting again. In the same way that tests are a part of the process that are invisible to your end users, these iterations are both invisible in the end product and critical to its eventual formation. The process of refactoring allows us to take a step back from our code, look at how to simplify it, and improve it. On a more macro level, code is temporary. Let the code that you've written teach you about the code that you want to write. Find ways to make each thing you create, each job you take, closer to yourself. This is how I imagine Kermit the Frog writes code. A lot of the code that gets written is the same. Maybe not literally character by character, but we are by and large repeating patterns that we've made before, variations on a theme. I've created this very trivial example where only one of the many lines on the screen is actually doing anything new or exciting. No matter how novel or innovative your application, there is a certain amount of boilerplate that is necessary. You need to be able to initialize your objects, manipulate the objects to interact with other parts of your application. A lot of this work is necessary, but feels more like translation than innovation. Some of this is for the sake of bookkeeping, and some of it has to do with the fact that a lot of the things we want to do with software are similar to each other in a lot of ways. And it can be really hard to feel creative in that paradigm. The code that you're proud of is probably a very small subset of the code that you write. As we think about the code we write and how we feel about it, we may begin to dwell on the idea of talent. The idea that true programmers must be proud of everything they write, and that a failure to come up with elegant solutions is an inherent quality within us, rather than a product of our skills and constraints at a given time. Over the long run, the people with the interesting answers are those who ask the interesting questions. The topic of talent and genius is ever present in both art and software. Imposter syndrome is especially common among software developers as with artists, so this point is important. Even though it is a waste of time and energy, we can often get caught up in these conflicts within ourselves, which can only prevent us from focusing on work and creating great things. The best we can do is reassure each other, remembering that others' strengths and constraints are their own. Focusing on others' talent is at best a distraction, as it adds nothing to our work and does nothing to make us better. If you're lucky, your career will involve tackling a series of unknowns. Anytime you get comfortable with one thing, complications will arise, or you'll have to move on to something else. The best skill you have to bring is not expertise, it's curiosity. So ask questions, and don't worry if you don't have the answers. There are many unknowns in this business, and no one is expecting you to have all the answers, so interrogate instead why things are the way they are. It's likely that the software you're working on and the developers working on it were subject to constraints that you don't know about. It could be that an obvious approach was missed, or that it was tried and found to be lacking. As we've discussed, the code that eventually gets written and the software that is eventually produced is nowhere near a complete picture into another developer's process. There's no way to tell from a finished product how easy or hard something was to write, or how many approaches were tried and failed. When you think of another programmer's talents or genius or innate abilities, you know nothing about the steps that it took to get there. Here's some insight into my process that you wouldn't see in a finished product. You serve as an example to your peers of how that process may look on an individual basis, but lots of the time you spend during a day is not likely to be accounted for in lines of code that are merged into a production application. You may spend lots of time deleting and tweaking lines to see what happens. You may spend time tweaking CSS rules and Chrome dev tools. You may spend hours whiteboarding, user testing, or taking notes. None of this is shown in a final product, but that doesn't mean it doesn't count in whatever psychic sense that implies. It's just a reminder that a finished application is only the tip of the iceberg of insight into what it took to actually make that thing. How this time is spent depends a lot on you, and your preferences is likely to inform your code in ways that you can't predict. All art is autobiographical. This is more evident in art than in code, but we bring ourselves to our work whether we mean to or not. All of the code you write is related to code that you've written before and the code that you didn't write. Think about how your life informs your work and how that can help you and the developers you work with. Think about the experiences you've had in your life and how it informs the projects that you work on. You're probably more likely to work on code that solves problems you're familiar with and have context for. We won't go too far into this because it could be its own talk, but it's important to consider as we think about how the technology field looks, how the world looks, and who technology helps and harms. Whether we like it or not, personal experiences inform all of our lives as developers. And by understanding each other's contexts, we can better communicate, which makes us better at writing software. I think about the word legacy and how it's perceived in both software and art. Legacy code is something to be feared. But even if your code doesn't survive, that doesn't mean you can't leave your own legacy. Think about what that legacy is. I want to leave you with this thought. Your job is to develop an imagination of the possible. Software is capable of doing a lot more than it currently does. As a developer, you have been given tools to work with that can drastically change people's lives. Software can inspire, empower, educate, and those tools are yours to wield. Not having the same skills and experiences as those who came before you can only work to your advantage. So make something that can only ever be made by you. Thank you again for having me. Again, I'm Valerie Woolard. I work at Heroku on the data infrastructure team. You can find me on Twitter as Valerie Codes. Feel free to drop me a line if you have comments or questions on this talk, or if you just want to see what I'm up to. I'm mostly looking at pictures of animals, but thank you again for having me and enjoy the rest of your day.